Welcome to this small work table, where today I'll be showing you how to make one of these for about $5. It's an infrared detector. Let's see it in action. Right, I've put it in the fork of this tree here, such that if I walk past, okay, there we are, it's set off, do it again. And one last time. Let's see about range. Yep. Quite the decent distance on these. Do it again. Right, let's go indoors. So, as you just saw, quite an effective device. It just takes 3 AAA batteries that go in this holder below. You've got the on-off switch on the back. You've got the light on the front, which goes off when something is detected and when it's calibrating. And you've also got the PIR sensor here. The buzzer inside is quite effective. The STL file, the actual 3D printing file, I will show at the end, and that has a small hole here where you can either fit a LED to show that the thing's running, or in fact it might work for allowing a bit more volume out of the buzzer. Anyway, let's make one. These are the components you'll need, and I'll put links in the description for where to get these from and the prices. So you've got your AAA holder box there, the infrared sensor itself, an LED of any type. Got a couple of wires there just for the breadboard version rather than a circuit board, and any NPN transistor, plus of course the speaker. This speaker is actually a buzzer type, so you give it about between 3 and 5 volts and the thing will buzz. Anyway, let's start to put these components together on this very tatty old breadboard. First thing to go in is this sensor here, and you can see written on it, it'll have something like ground, output, voltage in. So put that in first of all. Next, 2 little wires, one to the ground and one to the positive voltage. And that's down to here, which is where we're going to plug in our supply. So I'll plug those in next. There we go. The black being the ground and the red being the positive. What I've done here is actually completed the first video. I've put the negative of the LED on the left, and I've put the positive to the second pin of the sensor. And that actually, would complete the other build. If I turn on now, you see, there's the light comes on. Give it a few seconds, it should go off. And then the whole thing will be ready. There we are. And just to wave my hand, and there we are. So, that just tests your circuit. That's the thing as well. It tests your battery pack, your connections that way. And anyway, that would be the end of that first video. But now, let's add the transistor, the buzzer speaker, and we'll actually have to move that LED. Okay, the transistor is now in, and its connections are the leftmost leg. You've got the flat part of the transistor showing, the front of it. Its left leg into the negative input. Its middle leg, called the base, is going to the output of the sensor. That's the sensor's middle leg. And then this right leg, the collector, is in this slot here, which has got nothing else connected to it. That's the output of the transistor. Next, to fit the LED, and I've got a little tip here, and that is, if you look at the inside of that LED, the bigger section is always the negative, and the smaller section is always the positive. And that helps if you're salvaging LEDs, you get them from busted old equipment or something like that, because the usual advice is the longer leg is the positive. But of course with salvage they'll be shorter. Anyway, let's fit this LED. What you have is the positive side will go to the positive rail here, and the negative will go to the output of the transistor, so it's third leg. So you just plug that in. If I switch on now at this point, you'll see that the LED is quite bright. In my experience, these won't burn out at 4.5 volts from 3 AAAs, but you can add a resistor to one of the legs if you wanted to. and that would further protect, something like a 1K resistor would further protect it. But in my experience, you don't actually need protection on the LED for the DC voltage we're using. So now we just need to add the buzzer, and the connections of that are exactly the same as the LED. There we go, such that now when I switch on, you should hear an annoying beep from this while it calibrates. But that does show you your system's working. So now if I wave my hand across, you should hear the buzzer go off and the LED come on. There we are. Your build is done. Here's a closer view of the connections. I was hoping to do a fritzing diagram, but unfortunately the sensor had its legs back to front and I couldn't extend the legs of the NPN transistor. It was a bit of a mess, and I do apologise about that. It was the full intention, but what I have done though is drawn up a schematic. So here it is, these are the connections. Now finally, I was asked for the STL file, the 3D printer file, for this top casing, which goes on top of the AAA's holder. And I actually haven't got it anymore, but I've got an older version here from Tinkercad. I've logged in, and this is what I do have. So what it does feature is a hole there for a 3mm LED to go in. There is where the wires from the battery holder go through, and on the front we've got a spot for the LED which goes off when somebody or something walks in front of the sensor, and a hole there for the sensor to go into, which may have to be changed with a sharp knife or something to make it actually fit, but it's the same design. And if you just email at spiritinvestigations@protonmail.com, then I'll certainly send you the STL file. Good luck with your own build and investigations. See you next time.